Hello, and in this video we're going to continue in section 12.2, but we're going to be using arithmetic sequences, and we're going to be finding the sum of those sequences. So when we find the sum of the first n terms of a sequence, it's written s sub n. That's the sum of the n terms of the sequence. We're going to start with an arithmetic sequence. This is the one I've used in the past. A sub n equals 3, 7, 11, 15, 19, 23. We're going to try to find the sum of the first 6 terms. So the sum of the first 6 terms are 3 plus 7 plus 11 plus 15 plus 19 plus 23. Now we're going to do this by adding another second sum of 6 terms, but we're going to reverse them and in order. Plus 7 plus 3, and we're going to add these together. So we're going to do that, and each time we do this we'll get a common number here. So we're going to have 2 s sub 6's, 2 of the sum of 6 terms, but we're going to have, in this column we're going to have 26. In this column we're going to have 26. In this column we're going to have 26. This column we're going to have 26. So in each column we get 26. So we really get 1, 2, 3, 4, 5, 6 26's. So we can write this as 6 26's, or we can write them as 6 times the first term and the last term. Okay, and I kind of like that better because we want to be able to write a formula for this. 26 is not going to be common in every term, but it's always going to be the same as the first term and the last term. So that's going to give us two sums. It's going to be 6 times 3 plus 23, and then we're going to divide each side by 2 to get our solution. So if we wanted to write that for a sum common with an n, what we're going to have here is we're going to have 6 of them, so that's going to be the same as the number of terms, n. And we're going to have the first term, which we can denote by a sub 1, and we're going to have the last term, which we denote by a sub n, divided by 2. So this is going to be my formula. This is always going to work because of the way we line up the terms. We're going to get a common number. That common number is going to be the same as all of the first and last terms added up. So this first and last term is going to be that common number we add together. There's going to be n of them, and we're going to divide it by 2 because we had 2 sums in this list. So this is going to be my formula that I'm going to use for a sum of an arithmetic sequence. Alright, now we're going to use that to find the sum of our first 100 odd integers. So we're going to start off with writing out the odd integers. So we're going to get so many. I'm not going to write out 100 odd integers, but I need to know what this term is. I need to know what a sub 100 is. So we're going to look back in our previous section, and we had a formula for a sub n for arithmetic sequences. That was a sub 1 plus n minus 1 times d. Well, in this case it's going to be 1 for the first term, 99 for n minus 1, and the difference here is 2 each time. So we're going to have, I believe that's going to be 199. Let's just double check. 99 times 2 plus 1. So 199, I was correct. 199 is your final term. So once we find that final term, then we can use this sum formula. So we can go the sum of the first 100 terms is n, which is 100, times the first term plus the last term divided by 2. So we're just using this formula up here to find out what the sum of all of those numbers are. So we're going to have 200 here, so it's going to be 100 times 200 divided by 2, which is going to be 2, 1, 2, 3, 4. So it's 20,000 divided by 2. So your answer is 10,000 on this one. 10,000 will be the sum of all the numbers from 1 to 199 if you're doing odd integers. Okay, so let's move on and do an application to this. This is found in your book. It's an application problem for sequence or sum of an arithmetic sequence. This one says the corner of a football stadium has 15 seats in the first row and 40 rows in all. So there's 15 seats here around this corner, and then every one of them is going to have 2 additional seats. So we're going to have 2 more seats each time. So our sum is going to be 15 plus 17 plus 19 plus, and we're going to have our last term being a sub 40, because that's our last term in the sequence. So we need to find that last term in the sequence. We know the difference here is 2, and we know a sub 1 equals 15. So our a sub n, or a sub 40 is what we were looking for. It's going to be a sub 1, which is 15, plus n minus 1, which is 39, times our difference, which is 2. So we just need to figure that last term out. 15 plus 39 times 2 is 93. So we have 93 for our last term. So there's 93 in the last row around the back side here. Alright, now to find out how many seats there are, we would then take our sum of 40 rows, and that's going to be 40n times the first term plus the last term over 2. So this is going to be my solution to this. So it's 15 plus 93 equals times 20, because we're going to divide by 2. So there's 2,160 chairs in this, 2,160 seats available in this section. So whenever you're doing this, you have to know the first and last term. First and last term, how many terms you want. And if we don't know the last term, we're going to have to figure it out using the previous formula, a sub n formula. So you're going to have to know that formula in order for us to be able to figure out the last term. Alright, we're going to move on to geometric sequences next. Geometric sequences will be our next video.